What is Git and why do you need it? Git is a version control system. Before we jump into understanding what is a version control system, let's take a look at the life before there was a version control system. So you have your application server where your code will be running, and you'll have a developer with some sort of a folder with the name version 1.0 with her code inside it. And this code is deployed in this server, so now this server is running code version 1.0. Now her team member comes in and said, I have a great idea, send me your code. So this team member will have a folder named version 2.0 where he saved his version of the code, and this code is deployed into the server. But what if his code is not properly tested and crashed and burned the server? Rolling back to version 1.0 is super painful now because there is no centralized mechanism to do it because everything is maintained in this kind of folder structure. So in this case, rollback is time consuming. There is no audit tracking, such as there is no way to know which team member did exactly what changes in the application code, and it is not scalable for large teams. Hence, version control system were born. With version control system, there will be a special database called repository, and developers, instead of pushing their code directly to the application server, will push their code to this repository. And the code will be deployed from this repository to the application server. If another team member comes in and wants to work on the code, instead of requesting the other team member, he can fetch the code from this repository and then modify it, have a new version, and then push this new version, version 2.0, to this repository. And after this version 2.0 gets deployed in the server, even if something goes wrong, with a single command or a click, this repository can roll back the code to the previous version. So Git is a version control system, and that's why it was born. So why Git? Because it is distributed. So when we talk about version control systems, there are two different kinds: centralized version control system and distributed version control system. With centralized version control system, there will be a centralized repository and all the developers will connect to it. The challenge with centralized repository is this repository is a single point of failure and it requires constant connectivity. Some example of centralized repository version control systems are Subversion and Endeavor. In contrary to this, in a distributed version control system such as Git, in addition to having a remote repository, each team member will also have a local repository which is in their local machine. And they can do all their work, even push their changes to this local repository. Once they're happy with their changes in their local repository, they can push all their changes to this remote repository. Even if you lose the connectivity to the remote repository, it doesn't impact your work because all you need to do is push your changes to the local repository. And once connectivity comes up, that change can be pushed to the remote repository. So for distributed version control system, each developer has a local copy. It is more scalable than centralized because each team member is working separately with their local repository. Some example of distributed version control system is Mercurial and Git. So going back to our version control system features, why Git? It is distributed, it is performant, it has detailed audit tracking, it shows which developer did exactly what changes and when. Git is also open source, which means it is free. Some of the real-world use cases of Git are Kubernetes GitOps, Jenkins integration, and other DevOps tools. And various other repository is built on this Git, such as GitHub, GitLab, Code Commit, etc. So one thing which is very important to remember is Git is not same as GitHub. One thing to remember is Git is not same as GitHub. Git is a version control system, and GitHub is a Git repository hosting services which is built using Git, but GitHub has other features such as GitHub Action, which does DevOps. Git is installed locally on the system. GitHub runs on the cloud. Git is created in 2005 by Linus Torvalds, who also created Linux. GitHub is created in 2008. It is currently owned by Microsoft. Git is open source and used in multiple cloud repository services. For example, GitLab, Code Commit, etc. GitHub is not open source. It has free and paid tiers. Going back to the previous diagram, the implementation of this remote repository is GitHub, GitLab, AWS Code Commit, etc. For this course, we are going to learn Git with GitHub because that's the most real-world practical implementation, and you will get questions on your interview on Git and GitHub. So what are some ways to use Git? You can use Git using command line interface or CLI. This is super important because in your interview, you might be asked some particular popular commands. You can also use Git using GUI. We are going to go over a couple of those. And also, Git can be used directly from DevOps tools. Once you know the commands and how to use command line interface, you can basically use Git anywhere. Even within DevOps tools, you can run the commands that you're going to learn. For our course, we will use command line interface using Visual Studio Code. We will learn GUI tool called Git Graph. For repository, we are going to learn GitHub, and we will also learn how to integrate Git with DevOps tools such as Jenkins. Alright guys and girls, now that we understand what is Git and why we need it, let's take a look at Git workflow and history. At this point, we understand the high-level flow of distributed version control system. Let's take a closer look at the Git workflow. This lecture is pretty important because we will go over the core Git commands that you will use throughout the course as well as your real-world projects. For simplicity, we are just going to take one developer. So the left part where there is local repository, it actually looks like this. So everything on the left of the dotted line is in the user's local machine. So there are three distinct areas. First is workspace. So workspace you can think of as the local folder where the user is creating or modifying the code, in this case file 1. Then we have this index or staging area where the changes need to be staged. As the name suggests, the staging area will closely mimic the local repository. This will become clear in a minute. And then we have the local repository. Once you are done changing the file, you run this command git add name of the file. Once you run this command, the file will be added to the index or staging area. So at this point, the file 1 is staged. Once you are ready to move this file to local repository, you will run the commit command git commit name of the file and then -m and then a comment. This comment is quite important because in your audit tracking log, comments for each change will be displayed. Once this git commit command is executed, the file will be moved to local repository. And finally, to move the file to the remote repository, you run a push command such as git push, and that will move the file from the local repository to GitHub. Now note that even though this file has been now moved to remote repository, the staging area still has the file. As we said, the name staging should mimic the production as much as possible. Since the local repository and remote repository both has the file, so does the staging area. So let's say this user now modifies file 1, adds file 2 and file 3. So when the user runs git add file 1, file 2, file 3, alternatively you can run git add -a, that means all, that will stage all new, modified and deleted files. I'm going to come to this deleted part in a minute. So once this command is run, the staging area will have the modified file 1, file 2 and file 3, and then the user runs git commit file 1, file 2, file 3 -m, added new feature 1. Alternatively, you can just run git commit -m, added new feature 1. In this case, all the changed file will be picked up. So once this command is run, the changes will be moved from the staging to the local repository. And finally, when you run git push, all the changes will be moved to the remote repository. Now let's say you removed file 3 from your local workspace. Then you run git add file 1 or git add -a. Even though you are saying git add file 1, but since the file 1 is removed from the workspace, by executing this command, that will actually remove the file from the staging area. And furthermore, if you run git commit -m and then a comment, that will remove the file from the local repository, and then when you run git push, that will remove it from the remote repository. There are other ways to remove files rather than doing through git add, but keep this in mind. You might get this asked in your interview because this is kind of a trick question. Also, each commit will have their separate ID, full snapshot, along with details for audit. We are going to take a detailed look at the audit log when we do the demo next. There is another way to add files to the local repository, skipping the index or staging area. You can run git commit -a-m and then a comment, or git commit -am that will skip the staging area and the file will be added directly to the local repository. However, this is not recommended. Alright, let's jump into our very first Git demo. Before we can start having all the fun, first we have to install Git and configure a couple things. That's what we are going to do in this lecture. Let's get started. Download Git from git-scm.com/downloads. It's a pretty lightweight download and you can download based on your operating system. Throughout the course, I'm going to use Visual Studio Code. So you can download Visual Studio Code from code.visualstudio.com/download. Git will work with any other IDEs you currently have, but if you are following the demo and you want your screen to look and feel like the ones I'm showing in the demo, I would recommend using Visual Studio Code. Once both Git and Visual Studio Code are downloaded and installed, you can run git version in the Visual Studio Code terminal and you should get the version back. That means Git is successfully installed and ready to be used. Now we have to configure Git, but it is pretty straightforward. We only have to configure the username and user email because Git uses this information with every Git commit, and that information is baked into the commit history so that when you look at the history, you can track who made the change. To configure the username, run this command, git config --global user.name, and then put your name in double quotes. We are putting double quotes because we have a space in between the first name and last name. And this --global option ensures that any Git project you do in your machine, it is going to use this name. Alternatively, you can set this name for each project, but generally you have the same name for all your projects that you are doing. So we are going to run with this global option. Press enter. Alright, username is set. Similarly, to set user email, you run this command git config --global user.email and then your email address. Press enter. That's it. That's all the configuration you need with Git. You will also need an account in GitHub. So go to github.com and then sign up using email. It's pretty straightforward and simple process. Alright, with that being said, let's start the fun. Join me in the next lecture with our first Git demo. Alright, our very first Git along with GitHub demo. Let's start by creating a new folder where we will do all the work. To do that, I'll run make directory command and I'll create this folder named hello from Git. Then I will cd into it. If I open this folder in Windows Explorer or in Mac, this folder is empty. There's nothing special about it. It is not being tracked by Git. To enable Git tracking, auditing, all the good stuff of version control system, we have to run this git init command inside this folder. It gives us this message, initialized empty Git repository and the name of the folder. And you can also see a hidden folder named .git appeared inside our folder. From now on, whatever we do inside this folder can be tracked by Git. It is not needed to know what goes on inside this hidden .git folder because that is implementation details and subject to change. After you run this git init command, staging area and local repository are created and they are currently both empty. Now let's create our very first file in this folder. To do that, we will run code file1. This creates this file and opens up the file in the editor. We'll just type in hello world from Git. Press Ctrl S to save the file. Now if we come back to command line and type git status, it shows no commits yet, an untracked file. So at this point, everything is in the workspace. To add this file to the index or staging area, we have to run our git add command. So we'll run git add and the name of the file. And now if we run git status again, it says no commits yet, and it says changes to be committed, new file, file1. Another command that you will run frequently along with git status is git log. Git log displays all the previous commits along with the date, timestamp, etc. Commit is the most important part of Git. All the Git tracking, auditing, and all the details of who changed the code, everything gets started after you commit your file. So let's run the commit command. So we will run git commit file1 -m, our very first commit. Press enter and it says one file changed. Now let's run git log again. Aha! Now it displays a unique commit identification number for this commit along with who did the commit as well as the email address. It also displays the timestamp with the comment. If you recall, this name and email address were set as part of the global configuration setting that we did in the last lecture. At this point, file1 is in the local repository. Now let's complete the flow and push this to our GitHub repository. I'm in my GitHub profile page. To create a repository, go to this repositories tab and then click new. I'll give the name hello from Git. I'll keep everything as is. Scroll down, click create repository. And you will notice GitHub also displays the commands that's required to push your changes. This is super handy. We already did up to this part. We ran git init, git add, and git commit. To push our changes to GitHub, we need to run these 3 remaining commands. Don't worry too much about this git branch -m and git remote add command. They are part of branching. We are gonna learn about branching in couple lectures. For now, I'm just going to copy these 3 commands, go back to our Visual Studio Code and paste those and press enter. If you are doing this for the first time, you might be asked to provide your GitHub username and password, so enter those when prompted. Let's press enter. All right, seems like our changes have been pushed to our GitHub repository. Let's go check it out. I'm going to reload this page. Here we go. You can see the file1 is in our GitHub repository along with the commit comment. If you want to see the details, you can click this commit link and then click this blue identification number, and it is going to show what's changed, what file is added, etc. Also note that when you run git push, along with the file, the same commit ID from the local desktop gets pushed to the remote GitHub repository. All right, first demo in our books. Now let's do some further changes and see how you see the differences and add more files to Git. All right, let's jump into the next demo. At this point, file1 is in your working area, staging area, local repository, and GitHub remote repository. You notice that you misspelled the word hello in that file, and you want to fix it, and you fix this line. And you also added these 2 lines, Git is better with GitHub and learn Git and AWS to get a great job. So you save this file, and before you move this change to the staging area, you want to see the difference between the files. You do that by running git diff command. Git diff command shows the difference between the files in your working area and staging area. Let's dive deep to understand the output. The first line shows that it is comparing the same file, file1, in two different places. The second line shows the metadata and internal indexes that Git is using to run this compare command. This line is not really relevant to understand the differences. The three minuses denotes that a/file1 is the original file, and three pluses denote that b/file1 is the new file. The actual difference is easy to understand. The deleted lines are shown in red and added lines are shown in green. As we can see, the line hello world from Git is removed and three new lines have been added to this file. This section shows the summary of changes. This is divided into two areas. The minus denotes that this section is for the original file, and plus determines that this section is for the changed file. Please note that this -1 or +1 does not mean that one line has been deleted and one line have been added. The first number denotes that what's the line number that the change is from, and the second number shows the number of lines impacted. So for the original file, it shows that changes started from line 1, and since the old file only had one line, it doesn't show -1, 1. But the new file has more than one line, so it shows +1, as in the new file changes start at line number 1, and then starting from line number 1, 3 lines have been impacted. Since this file is small, you are only seeing this one section, but if this file was a large one and you changed in multiple areas of the file, this section will replicate with appropriate starting line number and number of lines impacted. It is not always easy to use this command line to show the differences, but later on we want to use some of the tools to see this. Also, we will see how the differences is shown in GitHub, which is a little bit easier to understand. Coming back to this file, we are happy with our changes, so I'm going to add this file to staging area. So if I run git diff again, there should be no differences because the same file now exists in both working area and staging area. As expected, there are no differences. Now to see the differences between the staging area and local repository, you run the command git diff -- staged. We are happy with the differences, so we are going to commit this file to local repository. And when you commit, it also shows a summary that one file have been changed, there have been 3 insertion and 1 deletion. Now I'm going to add another file, file2, to the working area. So I added these 2 lines and I save file2. So let's add this file to staging area by running git add command. And at this point, we are going to run git diff -- staged to see the differences between staging area and local repository. So there are no differences in file1, so it doesn't show anything about file1 here. And it shows that it's comparing file2 in 2 different places. Same things apply. Only thing to note is this line -- means is denoting the original file, /dev/null means there are no original files. It is a new file. And then in the summary section, -0, 0 means the original file has no lines. +1, 2 means the new file changes start at line 1 and there are 2 lines of changes, and the actual changes are shown in these 2 green lines. I'm going to commit this file and then we are going to push this to our remote repository. To push the changes, I'm going to click code, copy the HTTPS link, go back to my Visual Studio Code and run git push and then the HTTPS link. Alright, changes are pushed. Let's go back to our GitHub repository to see the changes visually. I'm in my GitHub repository. If I refresh this page, the changes are propagated. Now to see the commits, click this 3 commits icon. And to see the differences related to a particular commit, click the actual commit. And it shows the differences in file1 with little bit easier to understand format, but the same concepts apply. The blue color shows the summary of changes, red is deleted lines, and green is added line. Alright folks, this is how you check the differences before you implement your code changes. That's it for this one. I'll see you guys and girls in the next lecture. One of the most important concepts in Git and GitHub is branching and merging. So let's try to understand these concepts. Let's say you have a project running, you have a bunch of files committed in both local repository and remote repository. Then a team member comes and she's saying, I'm working on a new feature, feature 1. In real world project, you need a mechanism for her to work separately so that it doesn't impact the file 1 which is running fine. So to do that, you use branches. So when you push changes to the repository, by default a branch is created. That branch is called master. To work on additional features, you can create separate branches. So in this case, she can create this branch named feature 1. She can make all her changes in this branch, and then someone can review the changes, and if everything is fine, then merge to the master branch using a pull request. Now let's not get ahead of ourselves. Let's understand in detail how branching works in local, and then we're going to take a look at an actual example with GitHub. When you create a folder in your local desktop and then you commit a file, let's say file 1, Git automatically creates this branch called master. And this diagram represents the Git history graph or Git branch graph. You will see this in real world projects as well. The circle signifies the commit ID for each commit. So in this case, we have one circle because so far we have only committed once in the branch master. To create a branch, you run this command, git branch and the name of the branch. In this case, we are working on feature 1, so we are running git branch feature 1. And the branch will be created. Now note that the branch feature 1 is just looking at the same commit ID. So a couple of important things to remember. Branch can only be created from existing branch. By default, branch master is created and you are sitting on the master branch. So whenever you run this git branch feature 1, the new branch is created and it looks at the latest commit ID in the master branch. And branches are just references to commit. No code is copied. That's why when you create different branches, Git does it super fast. Compared to other version control system, when you create a branch, whole bunch of code gets copied, which is not the case for Git. When you have two different branches, you need to switch branches and work on different features. How do you know which branch you are on currently? That is determined by this pointer called head. You can switch branches by running the command git switch name of the branch, or you could do git checkout name of the branch. Git switch is more appropriate for switching branches, so that's the command we are going to use throughout this course. So let's say you switch branch to feature 1, you modified file 1 and you added a new file index.html, you commit to feature 1 branch, and all of this is happening in local repository. So how would the Git history graph look after doing all these changes? So at this point, the feature 1 branch will move one commit ahead of the master branch. This new circle is the commit ID for modified file 1 and index.html. What this means is, if you are at the branch master and look at file 1, you will see the older file. But if you are sitting in the branch feature 1 and look at the file 1, you will see the modified file 1 as well as index.html. If you want master branch to stay up to date with these changes, you need to switch the head to master branch, and you do this by running git switch master, which brings the head down to the master, and then you run the command git merge feature 1. Basically the command is git merge and then give the name of the branch where there are additional commits, and then those changes will be merged into the branch that you are sitting on. You do not need to give the name of the branch that you are sitting on. That's why we did not give the name master in git merge feature 1 command. Once you run this command, the branch master will move ahead and it will look at the latest commit. Note that this just made the master branch move to look at the latest commit ID. This is called a fast forward merge, And this is only possible because no changes were made on master branch. All it did was move the master branch to look at the latest commit ID and match with feature 1 branch. But what if there are changes in multiple branches? So going back to the previous scenario, while you made the change in feature 1 branch, you may switch back to master and do a change in the master branch as well. In this case, you committed file 2 in the master branch. So now the master branch and feature 1 branch is out of sync. How are you going to merge the changes? So let's think about it. Changes made on both branches, just moving the branch to look at the new commit ID won't do merge. So previously, all we did was moving the branch master to look at the new commit ID for feature 1 branch. Let's say we do that, but that doesn't solve it, right? Because then the branch master and feature 1 both looking at the commit ID for modified file 1 and index.html, and none of them are looking for the commit ID for file 2, which is not correct. Similarly, if you just move the branch feature 1 to look at the latest commit ID for master branch, then you leave the modified file 1 and index.html commit. So to solve it, we do recursive 3-way merge. We run git switch master, and then we run git merge feature 1, and what that would do is it will combine the commit ID for file 2 and commit ID for modified file 1 and index.html, and it will create a new commit ID for this merge. It is named 3-way merge because Git uses 3 commits to generate this merge commit ID, the 2 branch tips, and their common ancestor. Sometimes it will be called recursive merge, sometimes it will be called 3-way merge, but don't get confused, they are the same thing. So good news is Git will automatically choose whether to run a fast forward merge or a 3-way merge. You do not need to tell Git which one to choose. And once you merge all the changes to the master branch, you delete the feature branch. You do this by running git branch -d as in delete and the name of the branch you want to delete. So now a brain teaser for you guys and girls. Let's say the head is in the branch master and this is the current branch graph. Now if I run the command git switch feature 1 and then git branch feature 2, which commit ID, the blue one or the orange one, will feature 2 branch look at, and where does the head go? Pause the video and think for a minute. Alright, so when you do git switch feature 1, the head goes to feature 1. So currently you are sitting at the branch feature 1. And then when you run git branch feature 2, remember a branch is always a copy of an existing commit. Since you are sitting at the branch feature 1, the feature 2 branch will be looking at the latest commit ID from feature 1. And creating new branch does not change the head unless you explicitly switch to the new branch. Another alternate way of doing this would be git branch feature 2 space feature 1. So basically git branch, give the name of the new branch, and then the old branch to reference. In this method, the new branch will be created, but the head will still be sitting at the master branch. To do changes in the branch feature 1 or feature 2, you do need to explicitly switch the head to feature 1 or feature 2. Now that we understand how branching and merging works in your local, let's take a look at how this looks with remote GitHub. I have this file helloworld.py sitting in the master branch. If I run the git branch command, you will see there is only one branch master, and if I run git log --one line, you will see there is only one commit ID. At this point, I'm going to create a branch feature 1. And note that currently the head is sitting at the master, so when I run this git branch feature 1, this new branch will look at the latest commit from the branch master. If we run git branch again, you will see we have 2 branches, but the head is still sitting at the master. To switch the head to the feature 1 branch, we need to run git switch command. Let's run git switch feature 1. If we run git branch again, you will see the asterisk or the head has moved to feature 1 branch. If I run git log -- one line again, it is going to show you that the head is at the feature 1 branch and both the feature 1 and master branch is looking at the same commit. Now while we are sitting at the feature 1 branch, let's change this program as well as add another file. Alright, so I changed this hello world file. I'm going to save this file. I'm also going to add another file while I'm at the feature 1 branch. Alright, I created and saved this testpython.txt file. Now I'm going to add and commit these two files in the feature 1 branch. To do that, I run git add dot. That means anything that's changed, updated in my current folder will be added to the staging area. Let's commit these changes. Alright, so at this point, if we run git log again, so you can see the head is still at the feature 1 branch, but feature 1 branch has moved ahead one commit of master. Now while we are sitting at the feature 1 branch, let's run git branch command again. Git branch feature 2. So this will create a new branch named feature 2. Which commit do you folks think feature 2 will look at? I hope you folks got it. Remember that branch is nothing but references to a commit. Since the head is sitting at the feature 1 commit, feature 2 will simply look at this commit. So if we run git log -- one line again, as expected, head is sitting at feature 1, both feature 1, feature 2 branch looking at the latest commit, while master is one commit behind. So at this point, I want to merge the changes from feature 1 to the master branch. How do I do that? I switch back to the master branch by running git switch master, and I simply run git merge feature 1. This will be a fast forward merge, so the master branch will simply move to look at the latest commit. No new commit IDs will be added. Let's check it out. Let's run git log one line again. As expected, no new commit IDs have been added. Now all the branches, master, feature 2, feature 1 is looking at the latest commit ID with the head sitting at the master branch. At this point, I'm going to switch to feature 2 branch and make some changes. And I'm going to add and commit these changes. And I'm also going to switch back to master branch and do some further changes. And I'm going to add another file. I created this log file.txt, so I'm going to add and commit these changes from the master branch. So before we merge the changes from feature 2 to this master, there will be situations where some branches are merged, like feature 1, and some branches are not merged. How could you tell? You could tell by running this command. Git branch -- merged will show you the branches that have been merged to the master, in this case feature 1. And git branch -- no merged command will show you the branches that have not been merged to the branch where the head is at currently, which is master. When you run just git log command, it shows you the log for the branch you are currently sitting on. To see the logs for all the branches, use this git log -- all option, and then with this -- one line, I want to see the shortened log, and -- graph will give you somewhat a graphical representation. So if you run this, as expected, head is currently at the master branch is looking at this commit, and there is a diverging branch, feature 2 branch is looking at this commit. Now if I run the merge command, this will be a 3-way merge and it will create an additional commit ID. Let's check it out. I'm running git merge feature 2. Changes are merged, so I'm going to run the same git log command again. We have a new commit ID and the changes from feature 2 branch has been merged into the master branch. I'm sure you guys and girls are wondering, what if I changed the same file from these two different branches? How can it merge then? Well, that would create a merge conflict, and we will learn about merge conflict in a later lecture. Alright folks, that's it for this one. I'll see you guys and girls in the next one. Alright, so the situation is this. I have two files added to my local repository, file 1 and file 2. I want to delete file 2. So to remove file 2 from my folder, I can run the Unix command rm file2. Even though the file is deleted from the folder, Git still needs to track it that a file is deleted through the commits. So if I run git status, it shows that the file is deleted and we need to move the changes using the add command. Even though file2 is deleted from the folder, this still exists on stage and local repository. If I run git ls-files, which shows us the files from the staging area, you can see it still has file2. So to resolve this git status message as well as remove the file from staging and local repository, we are going to do git add. If I run git status again, so at this point this file is gone from staging. If I run git ls-files again, you can see file2 is gone. Now to remove the changes from the local repository, you need to run git commit. At this point, this file is removed from local repository, staging, and working area. If I run git log one line, you can notice that removal of the file2 also came as a commit so that you can revert back and track the changes. This method is little cumbersome. There is an easier way to remove the file from staging and working area in one shot. Now we focus our attention to file 1. Instead of running regular Unix rm command, we are going to run git rm. This command will remove this file from working area as well as staging. Git rm, the name of the file, press enter. Alright, file 1 is removed. So if I run git ls files, you can see file 1 is removed from the staging area. Note that file 1 still exists in the local repository. It's also evident when you run git status, it shows that the file 1 is deleted, but the changes still needs to be committed. I'm going to run git commit. Alright, the file is deleted. If I run git log one line again, you can notice the commit for file 1 removal. And if this local repository is connected to a remote repository in GitHub, you need to run a push command to remove these files from the remote repository as well. Alright folks, that's how you remove files from your Git directory. That's it for this one. I'll see you guys and girls in the next lecture. Hello folks, Raj here, instructor for this course. This Git crash course is part of a full course in Udemy. The full course is over 3.5 hours long. It covers topic from basics to advanced, comes with a certificate of completion as well as 30-day money-back guarantee. If you are not happy with the course, you get your money back, no questions asked. This course will cover 4 main areas. We will start with Git fundamentals, then we will jump right into real-world Git with GitHub, where you will learn everything you need to work on an actual project. Then we will dive into advanced Git, and we will end the course with the Git and GitHub interview preparation section. I will teach you all the concepts required, no prior experience needed. I have included the link and maximum discount coupon in the description. Also, in the spirit of holidays, all my courses in Udemy are on sale, including my highest rated Kubernetes with EKS course and best-selling Rocking System Design course. The link to the courses along with the maximum discount coupon are in the description. If you are looking to learn any of this topic, this is an excellent way to support me and the channel. Alright folks, thanks for watching. If you found this video helpful, please subscribe, comment and like. That's it for this one. I'll see you guys and girls in the next video.